Hello everyone. Now we are looking at solving linear inequations with one unknown. So, in the solution of linear inequations, all the rules are obeyed as in the solution of linear equations. However, the solution is now given in the form of a solution set since it can take up a range of values. Therefore, when we solve for our x or other variable, it will not only be the value of one quantity, but it can take up a range of values over different quantities. Also, there is one exception. If an inequation is multiplied or divided by a negative number on both sides of the inequation, then its sense is changed. That is, the inequality sign is reversed. Wondering what I'm talking about? Let's do some examples and this will help to solidify all of what I have been saying. So let's look at example 1. Solve for x. So we have here 5x plus 2 is greater than 47. So let's restate our problem. 5x plus 2 greater than 47. So again, as we said earlier, it's the same procedure to solve for x in this inequation. So we will transpose that positive 2 or that addition of 2. We will transpose it to the next side of the inequation. And you would remember from solving equations that when we transpose an addition of 2 to the right hand side, it will become the opposite operation, which is subtraction of 2. So we will have 47 and we will subtract 2 since the operation becomes reversed. When we simplify that, we will have 5x is greater than 45. So the next step is to get rid of that 5 by dividing. And we also have to do it to the right hand side to keep the equation balanced. So finally our answer turns out to be x is greater than 9. 5 9s 45, right? So x is greater than 9. So you see it's the same procedure for solving inequations as solving equations. But we can see, however, that x takes up all the range of values greater than 9. Therefore, we can write a solution set for this answer. So we could put our set notation. So we can say, we put our set notation here. So this means the set of, right? These brackets mean the set of, and then we're going to describe what set we're talking about. So the set of x values, right? Such that, so these two dots mean such that, so it's the set of x values such that x is what? X is greater than 9. Right? So it's saying that the solution set is a set of all values of x wherein which x is greater than 9. So all values greater than 9 are those for x. Alright, let's try another example. So here is example 2. Solve for x. So we have 3x, 3 times open bracket 2x minus 1 close bracket is greater than 6. Let's try this one. So we have brackets here, so we have to expand that brackets. So we have 3 being multiplied to each term in the bracket. So we're going to have 3 times 2x and 3 times negative 1, right? So we are distributing the 3 across each term in the bracket. So 3 times 2x will give us 6x. So let me just write that here. So 3 times 2x is 6x. And 3 times negative 1 is negative 3 or minus 3. And all of that is greater than 6. So now we can transpose that negative 3. So we have 6x is greater than 6. And when we bring it over, it's going to become the opposite operation of plus 3. So we simplify that. We will have 6x is greater than 9. Now let us see if we can get rid of this 6 by dividing by 6 and also dividing the next side by 6. So our final answer will become x is greater than 9 upon 6. 9 upon 6. Let me just write this 9 a little better. Now, sometimes we might need to represent this solution on a number line, as you would have seen in previous lessons. So we could write this in decimal form so that we can more easily understand how to represent 9/6 on a number line. So we could convert it to decimal and we would get 6 into 9 goes once, and so we would get 1.5. So x is greater than any value. X is greater than the value 1.5. X takes up the range of values greater than 1.5. Oh, and let us just think about the set notation for this. So therefore, we could say therefore, the set of values for x. So the set of values for x such that, so remember these two dots represent such that, so the set of values of x wherein which x is greater than 1.5. Right? So the set of values of x wherein which are such that x is greater than 1.5. Alright, let's try some more examples. So let us solve for x here in example 3. So we have 3x plus 2 is less than or equal to 5x minus 4. So the first thing we can do here, as in with solving linear equations or other equations, we can group like terms. So we can group like terms. So we will have 3x. And we bring over the 5x, which will become a minus 5x. Less than or equal to. We can bring over the 2 at the same time. So it's going to be minus 4 minus 2. Right. So now we're looking at 3x minus 5x. So that will give us minus 2x. Alright, so you have 3x's and you subtract 5x's from that, you will have negative 2x. That's one way you can look at it. Over here we'll have negative 6. So you can look at it that, hey, I owe 4 and I owe 2, so I owe 6 in total. Alright, so now let us see if we can get rid of this negative 2 by dividing by negative 2. And of course, we also have to divide the other side by negative 2 to keep the equation balanced. So this negative 2 will cancel that one. And now, based on our rule, over here it says, only when dividing or multiplying both sides by a negative number that the inequality sign flips. So this is what we were talking about earlier. That that's the one exception when doing inequations. So this sign, the sense of it will be changed, right? So we will have to flip that inequality sign. So now it becomes a greater than or equal to. And when we simplify negative 6 divided by negative 2, we will have a positive 3. So this is the one exception when solving inequations, that when you divide or multiply both sides by a negative number, the inequality sign flips. Very important rule here that we must remember. So let's try a couple more just to get this down solid. All right. Example 4, solve for P. All right, so we have 2 minus x over 5 is greater than 4. So we can start by transposing that positive 2 here. So that will leave us with a negative x over 5 is greater than 4. And when we carry over the positive 2, it becomes a minus 2. So now we have negative x over 5 is greater than negative 2. So what do we need to get rid of here? We can just go right ahead and get rid of that denominator 5, but we could get rid of the negative sign as well in one shot. So we could just multiply all of this by -5. So I'm going to write it here, multiply all of that by -5. All right, and if we multiply this side of the equation by -5, we also have to multiply the other side by -5. So what you will see happening here is that this -5 will cancel that 5 as well as the negative sign. Okay, so now we will end up having x, but should we write greater than? No. We have multiplied both sides of the equation by a negative number, which means that the inequality symbol, its sense will be changed. So now it will become less than. Now it will become less than. So x will now become less than. And we have a negative. Oh, just saw a mistake, guys. So it's not a -2, it's a +2. It's a +2 because 4 minus 2 is a +2. So we have 2 times -5 now, which will give us -10. Well, that mistake I made brought out a point. Not all the time when you multiply or divide both sides of the equation by a negative value means that your right hand side will become positive. You still might have x being less than or greater than a negative number when you do that. So in this case, x is less than a negative number. All right. Wonderful example there. All right, so example 3, this one involves a lot of fractions. So you can even pause the video here and see if you can attempt doing this one. It involves fractions, so there are a number of ways you can work it. All right, so if you gave it a shot, let's see. You could, we are seeing a lot of fractions here, so there are a number of ways. First off, let me see if I can write it in a simpler form. So we could have 2x over 3. So we can see all the fractions that are taking place. Minus 5. And we could almost put that as 5 over 1, right? And that's less than or equal to 3x over 4. So that 3/4 x can be written as 3x over 4. And I hope you do see why. Alright, minus 21 over 4. So now we're seeing fractions going all across. Of course, we could simplify the left-hand side by finding the LCM and also simplify the right-hand side as well. 4 is already the common denominator. Or we could just work all the fractions together by finding a common denominator for all of them. And the lowest common denominator I can think of for 3, 1, 4, and 4 would be 12. So we could multiply the whole expression by 12 to get rid of those denominators, because that's what we want. We want to get rid of all denominators in order to solve this. So when we distribute that 12 to each term within the bracket, we will have 12 times 2x over 3. The 3 will divide into the 12 to give us 4 times the 2x, and I'll just work it all out here instead of writing. So we'll end up having 4 times 2x, which will give us 8x. 12 times the -5 will end up giving us -60, less than or equal to. Now 12 times 3x over 4, well, the 4 will go into the 12 3 times, and then the 3 now is multiplied by the 3x, so we will have 9x. And then now 12 times -21 over 4, same process, 4 into 12 3 times, and 3 times -21 is -63. So there we go, we have removed all denominators. So let's see if we can group like terms and solve this once and for all. So we have 8x minus 9x is less than or equal to negative 63, and when we carry over that negative 60, it will become positive 60. So we are seeing negative x is less than or equal to negative 3. So how do we get rid of this negative sign in front of the x? Well, you could divide both sides by a negative 1, right? Or we could multiply both sides by a negative 1, which would still work out to be multiplying the whole equation by negative 1. So let's try that. So we can multiply the entire inequation, sorry, by negative 1. And multiplying the entire inequation by negative 1 will cause the sense of all of these elements in the brackets here to change. So 1 times negative 1 times negative x will result in a positive x. Even the inequality sign, the sense will be changed to become a greater than or equal to. All right, and let me just highlight it so that you can always remember to flip the inequality sign. And also negative 1 times negative 3 will result in a positive 3. So there you go, that's your solution for this question. Now let us write the solution set for this. So we can write it as a set of elements, set of values of x, sorry, such that, or where in which x is greater than or equal to 3. So that's how you do the set notation for that question. And of course, you know, math is all about getting as much practice as possible. So I have lined up some questions here for you to practice. So please pause the video, look at them, write them down, and practice these questions. Here are some others that will require you to graph your solution on a number line. Please remember as well that you should write the set notation for each answer that you get so you can practice the set notation as well. Alright guys, so that's it for this video. Please enjoy.